CTO of Big Data at Dell EMC and VP of Analytics at Yahoo. Thank you, Bill. And without further ado, I pass the baton to the presenter.
Thanks, Mel. Thank you very much for the introduction. And thanks, everybody, for joining, wherever you might be. We're going to have I hope, a provocative conversation. I'm going to hopefully challenge some of the way you think about what you're doing around data and analytics. And I'm going to start with this. I love this headline, this cover page from The Economist. The data is now the world's most valuable asset. And that has led, of course, to this famous phrase, data is the new oil. Now, when you think about data as the new oil, what does that really mean? Right? I mean, for the first time since I've been in this industry, which has been almost 40 years, somebody's attributing value to data. Now, for the most part of the last 40 years, and in fact, in many organizations today, data is still a cost of business, something to be minimized. And in fact, it's a liability in some organizations because you don't properly govern and take care of it. And if it gets leaks out, if somebody hacks into it, you could be substituted, have to face substantial fines. So there's this traditional way of thinking of data has typically been that it's a cost to be minimized. And data warehouses, by the way, they aggregated the data. You got 24 months of data. You got a sliver of data because it was so darn tootin' expensive to try to keep all this data. And then something happened. About 5-6 years ago, there was this realization that data is something unique, something powerful. And this data is a new oil sort of surfaced, right? And what this phrase means is that in the same way that oil fueled the economic growth of the 20th century, data would be the catalyst for the economic growth in the 21st century. That data was an economic factor of growth. But data is much more than oil. There's a lot of things about data that make it very unique and consequently much more powerful than oil will ever be. So if your organization believes that data is the new oil, that data is the source of the economic growth in the 21st century, then the most important question an organization needs to ask itself is this one, right? Which is, how effective is your organization at leveraging data and analytics to power your business models? In fact, this is, in my class, we spend the first class, just the slide we're gonna look at here, focused on this question. Try to help organizations understand how effective are you at leveraging data and analytics to power your business model. Now, what we found, and we asked organizations this question, the first thing they do is they look at you like you got lobsters crawling out of your ears. They don't have any idea how to answer this question. They don't know how to measure themselves. They don't know what good looks like. So what we did is we created what we call the Big Data Business Model Maturity Index. And the key phrase in there is business model. It's not about a technology maturity index. It doesn't measure how good you are with SQL or TensorFlow or Spark or who cares? Who cares if you can't figure out how to power your business model with data and analytics? And what we found as we built out this maturity index is that organizations tend to sit along one of 5 different points on the maturity index. And by far, the vast majority of organizations, 95, 97% of them, even today, still are stuck on the business monitoring phase. That is, they use data and analytics to tell them what's happened, right? They're building reports and dashboards, retrospective views of the business that tell you what happened. And trying to run your business with a retrospective view on what happened is like trying to drive your car using a rear view mirror. Just not very effective. And organizations have struggled to build off of that business monitoring mentality, that data warehouse, business intelligence, reports and dashboards. They've struggled to become more predictive, more prescriptive. They struggle to monetize the insights buried in the data. By the way, notice that face, it says insights monetization. It doesn't say data monetization. No one cares about your data. Data is not value. The insights in the data, insights about your customers, your products, your services, and your operations, that's what's valuable. That's what you're going to monetize. And eventually you're going to the organization digitally. to create a continuously learning and adapting organization, not only around the AI and reinforcement learning and deep learning capabilities that enable that continuous learning and adapting environment, but how we're leveraging those technologies to empower our frontline employees. So the challenge here is that most organizations think this problem is a technology challenge. And crossing this analytics chasm here has, for most organizations, become a technology chasm. And they've just been throwing tens, if not hundreds of millions of dollars in this chasm. And the problem is it's not a technology issue. The single most powerful word in the business world is the word economics. Because at the end of the day, economics is all about creating wealth or value. This is not a technology conversation. It's a value creation conversation. It's about creating wealth. And we're going to talk about how organizations can exploit the unique characteristics of data and analytics to create wealth. But if you believe, so let's say as an organization, this is what you want to achieve. You want to navigate along this path. A very well laid out way for how you do this, how you navigate from step to step, what you need to do as an organization, right? I've written about it gazillions of times. I've taught it gazillion plus one times. But if you believe that this is what you want to do, then how do you go about doing this? Well, here's the way that we approach it. And that what we want to talk about here is how do I take an organization from being data centric to being value centric? I don't give a hoot about a company who's data centric. Data centric, big deal. Data at best is a latent asset. It has latent value. Now, what you need to do is you need to figure out how to turn data into value. And if you want to turn data into value, use this. This is one. There's probably a lot of other methodologies out there. I'm not saying this is the only one. This is the one that I've been using for the last 20 years. Especially the last 10 years in the big data space, to figure out how to data and analytics, big data, IoT, reinforcement learning, deep learning, machine learning, all these things. How do I use it? How do I leverage that to drive value? And here's the key point. The conversation must start by understanding what it is your organization is trying to do. Trying to go to the cloud, not a business initiative. Trying to transition from WebEx to Zoom and to Teams, not a business issue, right? No, initiatives have definable, differentiated value. Improving customer retention by 2%, reducing the cost of inventory, improving uptime, right? These are the business initiatives. And the reason why you need to start with the business initiatives, because if you want to provide value, you better start in the part of the organization where value is important. You better understand what the organization is trying to do. It's all about, like I say, you talk about the big data. It's not the 3 V's of big data: volume, variety, and velocity. No CEO, no CXO that I've ever talked to gives a shit about the 3 V's of big data. What they want are the 4 M's of big data. Make me more money. So start your conversation on the business initiative. Understand what it is they're trying to accomplish. Every organization has business initiatives, things they're trying to accomplish. And then once you identify that, identify the stakeholders who either impact or are impacted by that. And the reason why you need to bring these stakeholders to bear into this process is 2 reasons. One, they're a valuable source of ideating how you're going to solve this problem, this initiative with data and analytics. They're critical. Without them, your data science team is just guessing. The other factor here is most big data, data science, digital transformation projects don't fail because of lack of technology. The technology doesn't fail. What gets them is passive aggressive behavior in the organization. So at this point in the process, you want to make sure you bring all those people into the process so that every voice has a chance to be heard, has a chance to be involved. And once you bring those people in, what we focus in on from a data science perspective are the decisions. We focus on the decisions these stakeholders are trying to make in support of that business initiative. The beauty of focusing on decisions by bringing the subject matter experts and the stakeholders into this process, the beauty of focusing on decisions is that every business stakeholder I have ever talked to knows what decisions they're trying to make. because they've been trying to make them for years, generations possibly. Who are my most important customers? Which ones are most likely to leave and try? Well, which parts are likely to break out? Where do I have excess inventory? Where should I put a new store, right? They know what decisions they're trying to make. The decisions haven't changed. What's changed by virtue of the data and the analytics are the answers. And so this whole process here, this whole value engineering process is all geared around identifying, validating, valuing, and prioritizing the decisions they have to make in order to support the business initiative. And once you understand that, everything else falls out. What analytics I'm going to need, what data I need, where am I going to put instrumentation, what architecture, everything else falls out. Once you understand the decisions, identify, validate, value, and prioritize the decisions. Now, unfortunately, most organizations, especially IT organizations, like to start at the bottom and then try to crawl their way up. I call that a hope strategy. You hope that you can start here and get to something of value. But remember, hope is not a strategy unless you're in the cosmetics business. Hope is not a strategy. If you want to figure out how to make money, instead of hoping you're going to find it, start where the money is and work your way down. All right, so let's now bring in some economics. Let's talk about how data science can impact your organization's economic value curve. Now, what's an economic value curve? An economic value curve is a measure of a series of dependent variables and the impact it has on an independent variable. So let's say our organization is a hospital or a manufacturing plant or a mall or a theme park, whatever it might be, whatever it is you're trying to improve uptime, right? Energy production, right? A utility. You're trying to improve uptime. And in order to improve uptime, what you can do is you can increase maintenance spend, right? And the more money you spend on maintenance, the more the uptime goes up. Until at some point, the law of diminishing return bites you in the butt. Because at some point in time, the more you spend on maintenance, you're not getting more for your bang, for your buck, right? You're getting less and less uptime increase as you spend more and more, right? In fact, at some time, it even can go negative because of crowding out. So what happens in a situation like this? Your economic value curve tops out. You can't spend any more on maintenance and still get an improvement in uptime, except you can. By leveraging data and analytics, we can actually transform the economic value curve. We can, by using data and science, we can do more with less. And we can actually transition. So you're actually spending less on maintenance. You're lowering your inventory costs. You're lowering your overtime costs. You're lowering your consumables costs, and you're improving uptime. How can you do both? Well, I got to tell you right now, as a country, we are faced with this situation of how do you do both? How do you improve quality of healthcare while improving the economy? Right? How do we change and transform our economic value curve, which you can see here is pretty flat and sucks, versus the rest of the world? By the way, I'm not sure what Switzerland did, but better find out, right? So we can transform our economic value curve by embracing the diversity of perspectives to look at improving healthcare while also improving the economy. They're not mutually exclusive. They're so intertwined that we can do it. We can, by the way, leverage data and analytics and very individualized analysis to create personalized welfare and precision medicine and predictive world health, right? We can do all these things, but it requires us to basically embrace how we leverage data science. And what is data science about? So what data science is about, it's about trying to identify those variables and metrics that might be better predictors of performance. Think about that for a second. All we do in data science is try to find variables and metrics that might be better predictors of performance. And we go through this process, lots of exploration, discovery, testing, failure-centric in the sense that we're going to try lots of things. In fact, if you aren't failing enough, then you're not pushing the edges enough. And we want to create environments that's continuously learning and adapting. And to do this, it embraces a very nonlinear process. I can't measure the success of my data science work by how many models I built, or how much code I've written, or how many hours I've worked. The only way, by the way, I know whether my data science analytic predictive model is good enough is if I understand the costs associated with false positives and false negatives. Now think about that for a second. If I have a model that gets me 90%, let's say that back at Yahoo, where I was the vice president of advertiser analytics, And let's say I can predict with 90% accuracy what ads you might be interested in. So that I serve you the right ad at the right time and place it in the right place, right? 90% accuracy. The cost of being wrong, the cost of serving you the wrong ad is nearly zero. Now transform that to a COVID situation where I got 90% confidence that the vaccine I'm going to give you is not going to kill you, right? Well, the cost of that's a little high, right? And so 90% confidence in my analytics for having a COVID cure that's not going to kill me is not going to be sufficient. I probably want to see lots of nines in that answer. So the only way that you know whether your data science process is done, is good enough, is if you understand the cost of the false positive and false negative so your model can help. And by the way, you're going to fail a lot. You're going to try lots of combination of things and you're going to fail a lot. But the key process we want to talk about here is how we bring the business subject matter experts into this process. I'm not interested in turning my data scientists into healthcare experts. When I go work with healthcare organizations, I don't need to have my data scientists be experts in healthcare. That organization has a whole company full of people who are experts in healthcare. What I need to do is to teach them how to embrace thinking like a data scientist so that when they're collaborating with a data scientist, when they're brainstorming with a data science, by the way, this technique here is highly leverages design thinking concepts. Because the one thing that we've learned at Hitachi Vantara in my many years in the data science space is that data science and design thinking have very similar processes. Both are geared on ideation. Both are geared on having a very detailed understanding of the problem you're going after. Right, back to a second here. Defining the hypothesis you're going to go after. We do 2 weeks of work in many cases on the hypothesis definition before we ever start our data science work. We do all this work before we start bringing science to the data. If we want to identify not only what we're trying to accomplish, what are the KPIs and metrics against which we're going to measure success and progress? Who are the key stakeholders? What are the assets around which we're going to build analytics? What are the decisions we're trying to make? What are the predictions? What are the, right? All of these things we need to do. We need to understand this first. And to do that, to build that hypothesis development canvas, we call it, requires a tight collaboration with the business stakeholders. And then what we're going to do is we're going to build very granularized analytic models on people, right? It isn't the volume of data interesting. It's the fact that I can build a very detailed profile on every one of my customers, every one of my patients, every one of my students, every one of my technicians. I can build a very detailed profile on every one of my wind turbines and jet engines and compressors and chillers and clutches, right? I can build these very detailed profiles, and I use these analytic models, or some people call them digital twins. I call them analytic profiles for humans, that basically details out their behavior, right? And we know how to do this because we've done it for credit scores for years. Everybody has a credit score. What's a credit score? Measures your likelihood to repay a loan. That same concept works great in measuring somebody's at risk of catching COVID, someone at risk of having a heart attack. So it's about how do we take that data science process and the whole volume of data, and how do we get down to that granular level by collaborating with the stakeholders to identify those key assets around which we're going to build the analytics. By the way, I could spend 2 hours just alone talking about this process and how critical it is for organizations to change how they view. I don't want to look at large volumes of data on aggregate. I want lots of detailed data because I'm going to predict at the level of each individual their likelihood to respond to a certain input. All right. This highlights kind of the current book I'm almost had done for like forever, it seems like. But I want to talk to you about my journey in understanding the economic or the value of data. And it all started with a research project at University of San Francisco. Now, one of the advantages of teaching is I have access to a lot of really smart, really motivated, and free resources. So when we launched this project, one of the things that's always bothered me in my career is that I've never been able to determine what is the value of data. Most organizations struggle with this. They don't really think through it. But without being able to determine the value of data, you can't justify more investment in data. You can't justify this chief data officer's chance to sit at at the mahogany row table and demand their fair share. So we launched this project, and research students are going on this thing, and I have my thoughts about what I think the answer is going to be, but I'm sitting back because I want to learn. And then what happens is one of these moments seems to happen, not nearly enough, but one of my research assistants come up to me, and what she says, Professor Shmarzo, this data is not like any other asset we have, and I can't proxy it. I said, what do you mean? She goes, well, data never depletes, never wears out. That same data set can be used across an unlimited number of use cases at zero marginal cost. When she said that, the light bulb went off in my head. I said, holy cow, zero marginal cost. This is an economics conversation, not an accounting conversation. I was fixated on trying to figure out how I put data onto the balance sheet of an organization. Because once it's on the balance sheet, then I have a way to influence how valuable a company is by putting data in the balance sheet. The problem with accounting as a valuation methodology, it's a value in exchange methodology. That is, the value of an asset like this cup of coffee, right? Its value is $4.95. How do I know that? Because that's what I was willing to pay for it. Well, money for coffee, I know. But anyway, so accounting is a value and exchange methodology. But I realized that when we start talking about marginal cost, that this is an economics conversation. And economics is a value in use methodology. That is, the value of an asset is determined by how much value you can drive from it. And it has this nice little economic multiplier effect, right? If you remember from your economics class, as the marginal propensity to consume starts to reach 1, the economic value of an asset starts to reach infinity. And we can see in a very simple example how if I had point of sale data for an organization, and I put it in my data lake, right, in its lowest raw form, well, actually curated, but the lowest level of detail, very granular level, every transaction by every customer, by every coupon, their loyalty programs. I have this data out here. I can use that data set to improve promotional effectiveness of my sales organization. I can improve by 2.5%. Now, what's 2.5% worth? Is it 500,000? Is it 50 million? I don't know. It depends on your organization. But I know it's worth value. I know that improving promotional effectiveness with that data set is worth 2.5, is worth some money, some value. But wait, as the Ronco commercial likes to say, there's more. I can take that same data set at zero marginal cost and reuse it to improve customer acquisition by 2%. Or I can use it in the call center to improve customer retention by 2.5%, or blah, blah, blah. You can see how this process works out. You can see how use case by use case, I'm taking the same data set and using it over and over again. Now there's some gotchas here. That data set needs to be curated, needs to be transformed and normalized and metadata enhanced and such. But once I've done that, I can use it over and over and over again. At a marginal cost, it's almost zero, if not zero. And what happens is it means that we have a whole different way to thinking about how we approach things. So the beauty of this approach is the first use case, sales around promotional effectiveness, paid the price to get that data curated and put in the data lake. And then every other use case gets that data set for free. Thank you very much. So now what happens is that on a use case by use case basis, I can start to build out my data assets and my analytic assets. I don't have to have this big bang approach where I spend $40 million to buy an outrageously expensive data and analytics environment, spend 4 years putting it in place and hope something at the end squirts out, right? Something of value at the end squirts out, right? No, this is not an ERP type of big bang projects. Use case by use case. I can identify the use case. I can identify, validate, prioritize, and value those use cases and use those use cases to drive my data investments and drive my analytic investments. And each one of those investments, each use case pays for itself. Oh my God, it's almost too good to be true. But that's the way it works. But it takes a different mindset. You need to think about these as economic assets. How am I going to use them? Having them is not of value. Using data is where the value is. And so what happens then is one of the things I want to talk about here is this wonderful statement by Elon Musk, which if you think about this statement, if you buy a Tesla today, I believe you're buying an appreciating asset. not a depreciating asset. So there, right away, your accounting mind goes, wait a second, all assets depreciate over time. You put them on a balance sheet, you depreciation schedules and depletion schedules. And the reason why he believes this is not because these cars are rare. They're not 1964 and a half Ford Mustangs. These cars are appreciating in value because of an AI module inside of them. It's continuously learning and adapting to the environment around it. And each one of these cars is smart. Each of these cars is basically an IoT platform with all kinds of IoT things going on, all kinds of edge analytics, and it's governed by this big brain model in the middle, this AI model. It's learning every time this car drives, every corner it takes, every lesson that car learns, it pushes back to the cloud where it gets simulated and then back propagated back to all the other 600,000 Teslas out there. And the law of compounding has a huge impact here that if I can make a 1% improvement 365 times, well, you can see the number here on the board. What happens is that this ability to continuously learn, adapt, and share those learnings creates assets that don't depreciate, but they appreciate. They get more efficient, they get more reliable, they get more safe, they get more predictive, and they get more valuable. Oops. What the chart is supposed to show you is a use case by use case basis. These red arrows for a second. So let's talk about this use case by use case approach. So let's say my first case I'm going to go after is vendor quality. And that's worth $60 million a year. Improving vendor quality by X% is worth $60 million a year. There are 3 data sets that I need to drive that. And there are 2 sets of analytics. Analytic A, we're going to call anomaly detection, and analytic B, we're going to call vendor quality score. Now, if that's worth $60 million, I can do a straight line allocation back to sets. They each get 20 million, 3 data sets divided by 60. And my analytic assets, 2 of them required, they each get $30 million. Now, you can get really fancy. You can use random forest or PCA or some other technique to figure out exactly how much to allocate to it. But this is pretty good, good enough. Now, my second use case, it's around vendor reliability in delivering their parts on time as promised, right? So I figure I can, that's worth $20 million a year to improve vendor reliability. To do that, I realize I need 2 data sets. I'm going to reuse data A. It's in black. I get that for free, but I need to add data set D. Right now, we can start to see that I can again attribute value. So A gets 10 million for the 20 million, and D gets 10 million or the 20 million. But now I can start to see A starting to increase in value. And the same thing with my analytics, my anomaly detection that I reuse again, and I build in module C is a vendor reliability score, right? I can allocate the value to them. Use case by use case. You can start to see how this process works. Use case by use case. Each use case pays for itself. I've got composable data and analytic architectures out there. I don't need to do big bang. I can build them out use case by use case. And then what happens is that in use case 3 around optimized inventory, one of my big giant brain data scientists working with some business people figures out how to improve the predictive effectiveness of my module A, my anomaly detection. They improve it by 1%. And every other use case that used that module just got 1% more effective for free. This is a game-changing aspect. We've got data and analytics that I can use over and over and over again at a near zero marginal cost. And to make things even better, I can actually increase the assets, which leads us to what I call a phrase here, that what's happening in knowledge-based industries. One of the most powerful changes in front of us, right in front of our face, is that the economies of learning are more powerful than economies of scale. Your ability to explore, try, test, fail, and learn and adapt faster than your competition will differentiate the winners from the losers in the 21st century. The economy is learning more powerful. This has led to what I call the Shmarzo economic digital asset valuation theorem. Yes, my blatant attempt to get a Nobel Prize in economics. And the fact here is that the more the data and analytics get used, the more powerful, accurate, and effective they get. It has this Shmarzo digital asset valuation theorem has 3 effects. Effect number 1, on a use case by use case basis, by reusing the data and analytics from the earlier use cases, I can flatten my marginal costs, right? That all the data I'm going to need at some point gets in my data lake, and I build out all the analytics I'm going to need, right? So What happens over time, your marginal costs flatten out because your data is already there and the analytics are there. The second effect is how my economic value grows, because by the reuse of the data and analytics, I'm shrinking time to value and I'm de-risking the use case implementations. So your first use case, for example, might take 9 months, because you got to build out the data lake, you got to put the 3 new data sources in there, you got to build a couple analytic modules. And then your second use case, maybe that takes 6. You're going to reuse from the 3 use data sources. We might have to add 2 more data sources. We might have to build a new analytics. So you can start seeing use case by use case. Because of the composable nature of the technology, I can build out use case by use case my data and analytics. And then, of course, we get the TensorFlow Tesla effect, that by building assets that are continuously learning and adapting, assets that appreciate in value, I'm actually creating this ripple effect. Where every change I make in improving the predictive accuracy, reliability, and effectiveness of each of my analytic modules ripples back to all my other use cases. It is literally printing money. And there's only a couple of companies out there that seem to understand this. Obviously, Tesla has figured this thing out, which is why they, are they a car company? Are they a data company? What are they? Well, they look like an analytics company to me, knows how to build these assets that appreciate in value. And Google with their TensorFlow also, to me, cracked the code. You think about TensorFlow, right? The single most important technology inside of Google. And what do they do with that single most important technology that fuels their search, it fuels Android, it fuels everything that goes on in them? They open source it. Think about that for a second. Traditional business person literally comes unglued. They fall off their chair thinking about open sourcing their most valuable technology. But Google's playing a different game. Their chessboard is 3 dimensions different than ours. And what Google realizes is by open sourcing TensorFlow, they have more people testing TensorFlow across a more variety of use cases, and TensorFlow continues to get smarter, more efficient, more valuable. And who's the master at leveraging TensorFlow? Google. Anyway, hopefully got a lot of time for Q&A here. I wanted to get through a lot of the stuff pretty quickly. It's hard to go through this. This is about a 30-hour class. You just got you got a 30-minute deep, like a drink of water from a fire hydrant. So let's take some questions here. These are the best part for me, by the way, the questions that people ask. I'd like to know, what do you think? What are your questions? What bothers you?
Hi, Bill. I have a few questions. Let me start with the first one. And it's coming from university professor from Chennai, India. How to distinguish between maturing data and aging data? That's by Dr. TV Gopal.
Maturing data versus aging data. That's a good question. So there is a belief that data is old and has less value as it gets old, until we get into COVID-19. And then some organizations realize that it's a brand new situation. What do we do in a brand new situation? Well, we go back to history and we look at what happened with the swine flu. We look at the SARS situation. So sometimes the old data may not necessarily lose its value. The value of data is highly relevant to the use case it's used by. In fact, one of the common phrases is, how do you determine signal from noise in the data? Data is all kinds of noise in data. So what do you know the real signals are? Well, if you don't know the use case you're going after, there's no way to determine what's important in data. And so sometimes when you have this mature data, you may not want to put it on hot storage. You may want to put it somewhere cold, but there may be a point in time where you need to pull that data up because it provides a proxy for a problem you're facing today, where for all which you don't have any data. And again, I'm going to use the COVID-19. I think some countries, China being one of them, I think Korea, South Korea, I think Hong Kong, Taiwan, I think these countries use that data, their experience from those previous swine flu and from the SARS situation, and they figured out how to attack this problem much more quickly than the rest of the world. So again, there's data you got that over time would seem to be less valuable than probably is, but there's all kinds of situations where old data might be valuable. Like think about Olympics, right? We have the Olympics every 4 years. Well, that data for 4 years, for every 4 years for the last 20 years, might be useful trying to predict behaviors of what people are going to buy, the wear and tear on the transportation systems, the demand, things like that. So I always tell people, don't be quick to get rid of your data, because that data may be a very important proxy for problems that you have not yet realized you have.
Okay, thank you. I have another question, which is very much IEEE specific, but I think you should be able to address it. How do we quantify security and ethics in the design process, as they are important parameters as well? IEEE has cybersecurity initiative and global initiative on ethics for autonomous and intelligent systems. Both are encouraging designs from those aspects.
I love the ethics question. There are smarter people on security, but let me talk about ethics for a second. In fact, let me go back to a slide here. This guy, this AI agent will do whatever its utility function tells it to do. The AI utility function is not designed by the AI agent, and it's not defined, should not be defined by a data scientist. The AI agent, the utility function, needs to be defined across a broad range of users. So let me give you an example. When I work with an organization about defining the AI utility function, this is the trickiest part. The AI models won't fail because the software doesn't work, the models don't work. They'll fail because you poorly define the AI utility function. When I say define the AI utility function, I like to look at the utility function across 6 dimensions, and they're purposely going to conflict. There's going to be ambiguity. Why? Because there's ambiguity in life, and you have to force that. So here are the 6 factors. There's 3 that are obvious. I'm going to measure effectiveness based on the financial economic impact. I'm going to measure it on customer impact. I'm going to measure it on operational impact. Those 3, everybody gets right. No brainers, right? Then I say, well, what about environmental? What about society? What about spiritual? I say, spiritual? That's one who always gets it. I said, yeah, there's a very big difference between do no harm and do good. Now think about that for a second. You want to make sure that your AI agent is programmed to, do good, not do no harm. If you don't understand the difference between do no harm and do good, well, go review the parable of the Good Samaritan in the Bible. There's a huge difference. So when we start talking about ethics, if we don't carefully think through the AI utility function, how we define that, and bring in a diversity of perspectives into that conversation, we will have horrendous unintended consequences. And yes, we'll have Terminators walking up and down the street wiping out humans because we haven't thought through all the ramifications. So this ethics problem in AI is not a simple solution. It isn't something you can show up and throw up on. It's going to take debating and lots of conversation in order for us to really carefully define the AI utility function. So we build these AI agents in a way that they do the right thing, and we've thought through the 2nd and 3rd level consequences, which, by the way, means no politician should ever be involved in this process, for what that's worth.
Okay. Please, if you have any questions, type them in either in Q&A or chat privately to me. I have a few questions for you. First of all, I just happen to be part of the autonomous systems community, and we've dealt with these utility functions for decades. At those times, they weren't called AI agents, they were just called autonomous systems. Right. So can you differentiate what does AI agent in this utility function add compared to traditional autonomous systems?
So an AI agent is probably leveraging deep reinforcement learning techniques, in a trial and error sort of environment to figure out and learn about its environment. If you bought a Zumba, vacuum, for example, you can watch this in live action as it bumps around the house, learning and mapping out the house. And so the thing about in autonomous systems, especially cars, is that we can't afford to have cars learning on the road. Right? Oh, I shouldn't have done that. I don't want to drive off that cliff. You don't want to plow into that bus, right? So what happens in the autonomous worlds is the idea of building simulators becomes really critical. You have to be able to build simulators. Now, what I found really interesting in the early, and you probably know this, even better than me. In the early days of autonomous vehicles, a lot of the training of these vehicles was done using the video game Grand Theft Auto. Right? It was a fail-safe. You could run billions of simulations. Now, it had some different rules in there than what you'd want to have. Right? Its utility function wasn't quite as robust as what you need. But the idea there was that you can build simulations that allow these assets to learn without having to endanger others. And this is kind of the beauty of this slide here of what Tesla's doing. And they're building this massive cloud simulator. So every night they're doing more and more simulations and getting smarter and smarter. So when the costs of false positives and false negatives is so high, we can't learn entirely within the real world. We're going to have to build simulators, and building simulators is hard work, right? You're going to have to take some data. Now we can use GANs to help enhance that data. There's all kinds of data techniques out there. But again, I think one of the key things is for these apps to become truly learning assets, we have to make sure they operate within environments so they can try and simulate different things.
Okay, I have many more questions. From Eric Moore, in your experience, does systems thinking play an explicit role in hypothesis development?
Oh God, yes. Systems thinking. Now, how to answer that question. So the hypothesis development canvas for us, we develop our hypothesis. We try to do that in a way where it's inclusive of all of our stakeholders. They have a chance to feed in. Part of our attitude and approach is, all ideas are worthy of consideration, which, by the way, doesn't mean all ideas are good. Right? You have to fail a lot. So I'm not a systems expert at all. So I'm going to quickly get outside of my space here, but a systematic approach. Going back to this slide here, having a systematic approach is critical. I have to be able to drive scale and repeatability. If I don't have a systematic approach, I can't train others. I can't scale it. And scale is going to be one of our biggest challenges in the world of AI and machine learning and such. We can't create enough data scientists, senior data scientists to do all this stuff. And so we're going to have to rely on systematic approaches for understanding how we decompose. Think about the idea of, for us, we think about building composable, reusable, continuously learning analytic modules that they act almost like Lego blocks, right? That we can, if we build them at a lower enough level of granularity, that they stand on their own, that they can interact with other Lego blocks to help us solve and construct bigger problems. So I'm not sure if I answered your question, but I do think that having a systematic approach for how you address and build these assets, these composable, reusable assets, becomes critical if you want to try to drive scale across the organization.
Okay, we have an extremely interesting set of questions coming in. I really like the following one from Jay Shaw. How much do you think data is responsible in order to build interpretable AI or explainable AI, maybe from a healthcare domain perspective?
So explainable AI, interpretable AI. So my thoughts on this is it's not the data that I'm worried about as much as I am the models and the opaque nature of, for example, deep learning models, not knowing how it's figuring out what variables to weigh and how those biases are handled. So the data, I have some confidence that with the right amount of work on the utility function, I can work bias out of the data. I feel comfortable about that. But understanding the variables that are driving the models becomes critical when we have models that are analytic modules that are kind of black boxes. And that's going to be a huge problem. Think about it just from the Fair Credit Reporting Act, FCRA. Right? When somebody is given a loan, right, the person who has their loan rejected has the right to ask, why was I rejected? And there's all kinds of rules and laws about that govern that, so that people who are aren't treated unjustly because of race or gender or age or other factors, right? We have this Fair Credit Reporting Act. So more and more of these organizations that are determining loans and such are falling into using deep learning models. Well, that doesn't excuse the fact you still got to explain why you didn't give me a loan. Right? If you can't explain that, you're probably going to get sued, and it's going to cost you a lot of money. So we're seeing this need for more visibility, more transparency into the models, because there's laws out there like the Fair Credit Reporting Act, like healthcare. The Defense Department is very, very big on explainable AI. They want to know why airplanes are making certain decisions because they're going to be held accountable. So we've not cracked that code all the way, but we understand how important it is for us to be able to understand what are the variables that are driving the models.
Okay. The next question, also interesting one, again from Gopal Tadepali. The calculus in RDBMS, Relational Database Management Systems, was the best confidence building method. The mappers in the big data are not so strong. Why are we persisting with this approach?
Help me understand. I'm not sure I follow the question, so help me understand that. I understand the RDBMS, Relational Database Systems,
was the best confidence building method.
So we knew with confidence that when we constructed SQL using those relational database systems, we would get answers that we knew were accurate.
That's right. And
okay.
Then the follow-on, the mappers in the big data are not so strong. Why are we persisting with this approach?
Well, okay. So again, I apologize if I don't have the question right, but when a lot of the challenges that we're facing in the big data and analytics space is around predictions, right? Predictions are never 100%. Yogi Berra famously said, predictions are really hard, especially predictions about the future. And the challenge we have is we don't know with 100% confidence that whatever that model came up with is going to be accurate, right? We have confidence levels, we have confusion matrices, we have things that help us get a comfort level. But when is good enough actually good enough? It's never going to be 100%. So a lot of the work we did in the BI space around relational databases was, relatively speaking, very simple, right? Set theory kind of stuff was being generated, and we had a high degree of confidence that we were getting back results that we could trust. But now we're looking at all kinds of different data sets. We're looking at structured, unstructured data sets. Some of those data sets do have biases in them because they come from humans. There's very natural in there. So there's a lot of work to prepare the data, which is why I think, by the way, the most underrated job in the data science space is the data engineer, right? And their job of bringing all these different data sets together. And then with those data sets, even then we're trying to predict. We're trying to predict who's likely to repay a loan. We're trying to predict who's likely to catch COVID. We're trying to predict when that part's likely to break down. So when you get the predictions, you, by your very nature, are not dealing with things you can trust 100%. And so that's where, again, you have confidence levels, you have understanding the cost of false positives to really help drive, when is good enough actually good enough when you're making these predictions.
Okay, thank you. The next question from Piero Bonisone. Data is tracking dynamic systems over time. An analytic model is a snapshot in time of that data. For example, digital twins. As time advances, the physical systems are modified, upgraded, etc. How do we maintain a fleet of digital twins over time to avoid their obsolescence?
Good question. So we update our digital twins continuously. They are the assets around which we're trying to build continuous learning and continuous adapting. We look at the variables inside of a digital twin. Now, not all variables need to be updated, right? Somebody's age is not going to change. Somebody's birthday is not going to change. But there are other variables that do change. And so you need to have thought through from a digital twin perspective, what are the variables that are going to change and change dramatically? We're in an election year right now. There's all kinds of crap being thrown at us from social media and news media. And we're constantly having some of our biases being tested. And so what you're going to find is that in models like that, there are certain variables that you're continuously updating. For us, these digital twins and a lot of the variables that sit inside a digital twin, again, this is the one for a human digital twin, right? We're basically, each of us, for example, inside the Amazon world, there's a digital twin of us inside of Amazon. It's like there's one inside of Google. Like I had, when I was at Yahoo, I had 500 million digital twins of all the people who came to our sites. And each of these different scores get updated depending on how important they are. Like you're not going to change your heart attack score very often. Maybe you change that quarterly or semi-annually, but you may have other variables of which you do have to update. So your digital twin needs to be smart and be continuously learning. Again, if we believe that learning is how we're going to be successful, it is around these assets, whether they're human assets or device or mechanical assets, around which we got to build these continuous learning asset models.
Okay, so I have a few questions as well. And you have partially addressed them already, but I'm just curious to.
By the way, these are really hard questions. These are really good questions. I'm not sure I'm ever going to do an IEEE again. You guys really have thought through your questions. This is very interesting.
You promised me to repeat this same session next week. So get ready.
You could give you guys a week to think about. This is good though. I mean, I'll be honest with you. I don't know all the answers. In fact, nobody does.
Nobody does. I agree.
We're all trying to learn this thing. So when I give you an answer, that truly is a snapshot in time of what I think today. And I reserve the right as I learn more things to change my mind. God, I hope I have the ability to change my mind as I learn more. I worry about that as our society doesn't see the ability to learn. But again, I'm a really big believer that these economies of learning, it isn't just machines that we're building that are learning. We're leveraging design thinking to build humans who can also continuously learn and adapt. We have to if we're going to survive as a species. But anyway, sorry, that wasn't the question you asked me. I just went off on a tangent.
No problem. I have 3 questions, 2 are very related, but I'll start with the third one. So you said that you can eliminate bias out of data. I'm just curious how you're going to do that. I assume first you need to identify what kind of bias that is. Then you need to understand the context and many other aspects. So can you enlighten me how you're going to do that?
Yeah, I mean, you have to understand the biases in the data. It's not an easy process, obviously, but the fact that you're aware there's biases in the data allows you to start to model that. And you can try to find unbiased data sets, which by the way, are really hard because the problem with dealing with humans, so biases in machine IoT data, very easy, not very easy, easier to handle based on the environment they're working in and such. I can work the biases out. They have to do with things like it's more humid in Orlando than it is in Tampa, right, or in Phoenix, for example, right? But biases with humans, here's the challenge with biases with humans. They are what define us as a species. We naturally move towards biases. That's just the way society has. That's how we process data. We categorize and we stereotype because there's so much data out there, which leads to these biases. And they can be uninformed biases. They can be old biases. But what you need to do is you need to understand, first off, people have biases. So you got to factor that in. Now, how much bias you take out of the data depends on the use case you're going after. There's some cases where if you're trying to sell digital, ads and such, I'm going to leave the biases in there. So I'm going to sell into your biases, right? I'm going to sell into your biases. But if I'm trying to make policy decisions as a government, then I need to be even more careful about the biases in my data to make certain that I have normalized out those biases. So they're not making uninformed decisions. And to do that requires organizations to model not just the first level of decision they're trying to make, but to actually walk down a tree of understanding the decision they have to make sure they understand where the biases pop up in that decision process. So again, there are certain situations where biases, I'm going to leave them in there because that's the way humans work. But when I start getting at the level where I'm making these very important policy or operational decisions about humans, I need to work extra hard to make certain that I factored in through that second, third level of impact, where the biases are going to have negative impact, and then I have to focus in on trying to remove those biases. You can't remove it all because there'll be analysis paralysis, never get anything done. But you've got to model how these policy decisions work their way down. And I love the idea of focusing on decisions because I can build a tree of decisions to know that this decision leads to these decisions, and now I can figure out what data I'm going to need for those decisions, and now I can figure out where the biases are going to have the most impact.
And biases are probably, I mean, definitely also function of the time, because what data you have now or what conclusions you can derive from it is different from what happened before December, for example. It will definitely be different from when vaccine is discovered and et cetera, et cetera. So how do you capture the context for that bias? Because it's not just enough to capture the data, you need also to capture metadata and the context for both.
Yes, the metadata around the data becomes critical, but it also is also driven by the use case. Right? We're constantly changing. Right? Yes, things are different, 9 months ago than they are now, and they'll be different 9 months ago. But I can go back when we had the financial meltdown in that 2009, 2008. We had all kinds of things are constantly changing. In fact, the only constant is change. And so what happens is you have to think about your models as constantly being peppered with changing biases, changing perspectives, changing environments. The metadata will help you certainly in context of where that data was captured, but it is there is no steady state. That's the human nature. We're never in steady state. Things are always changing. And so our AI models need to be at least aware of what we as humans are already aware, that there's not a steady state, and we're constantly going to have to be. This is why this continuously learning and adapting environment is so critical. You can build a model today, a static machine learning model, for example, and it's out of date. The model drift kills you, right? And we know that. So that's why this idea of building, through AI and reinforcement learning, these models that are continuously learning becomes critical, and why defining that utility function becomes critical.
Okay, I have noted also 4 other questions, all from me, but I realize they are one and only.
How about 2 more before I run out of steam here?
No, I'll only ask you one.
Okay, fair enough.
And it's all related to the data versus noise, data versus information, and then how much data is valid before it really expires. For example, your Tesla model, where you continuously collect data, but not all is interesting. So from the system's perspective, how do you filter out data at the edge, not to take it into the cloud or wherever you want to produce it?
So if I understand the question correctly, and the context becomes everything. And what I mean by that is the problem you're trying to solve and how often you're solving that problem probably dictates more than anything else where you're storing the data and where you're keeping it, what has to be hot and what doesn't.
7 p.m.
Thank you. The use cases become this the definition of the context. If you understand the use case you're going after, that gives you the context to figure out what's noise from signal in the data, what old data might be useful. And by the way, the word might is very powerful. If I think about what data science is, again, we talked this earlier, data science is about identifying those variables and metrics that might be better predictors of performance. So I want to have lots of data so that when we have a hurricane in Houston, and I can go back to when I had previous hurricanes in Houston to understand which communities might be most at danger of having their power go out. So again, a lot of the context of what data is important, what data is not. In certain contexts, the data set may have no value, but in a different use case, it might be the single most important variable. But if you don't understand the use cases, you don't understand the decisions people are trying to make, then you don't have the ability to put in context. And then you're just guessing, which, by the way, is a reason why I think, from my data warehouse days, no one cared about data governance because every data was treated equally and people got overwhelmed by it. Now we're trying to say, wait a second, if I take a use case by use case approach, I now have a way to validate and prioritize what data I want to go after and invest in those data sets with metadata and governance and enhancements and enrichments to make that data more valuable. I'm not trying to boil the ocean, right? I'm just trying to be very use case by use case centric. And then that use case by use case approach allows me to take the learnings I've learned in my first one and reapply to the second one, reapply to the third one, and at some point ripple those learnings back to my other use cases.
Thank you very much, Bill. Highly appreciate your very detailed answers and all your insights. It's a tremendous amount of knowledge and wisdom that you have shared with us. So the Santa Clara Valley Corporate Liaison Program thanks you and thanks all the audience who attended it. You will give us opportunity to display your presentation, the recording of this presentation to the community, especially for those who weren't able to attend it. A lot of people from Europe communicating regrets that they really can't attend at 3 a.m. So they liked you. They really wanted to listen to it. So thank you again, Bill, and everyone else for attendance.
Yep.
Bye.
And what I'll do is I'll make the presentation available to the audience. You stuck with this for an hour, so you deserve to at least have the slides. So I'll make sure you get the slides.
Thank you, Bill, and thank you, Shmuel, for organizing the talk. Bye, everyone.